Alrighty, we are continuing our study of statistics. Yesterday, what we did was we talked about the difference between a statistical question and a non-statistical question. We talked about numerical data and categorical data. So we got pretty good at knowing what the data was and collecting some data from students in class. What we're going to do today is talk about what do you do with that data. So the start thinking part says Sandra surveyed her class and asked how long in hours their phone battery lasts. She recorded all the data below. And it's 10 hours, 7 hours, 15.5 hours, 9 hours, 5 hours. And it's just this big long list of numbers which represent the number of hours that their phone battery lasted. So the first question was, what is the general battery life of the phones? It's really hard to figure that out just by looking at this long list of data. Next one, 50% of the phone battery lasts more than what amount? I don't know. I can't figure it out. See, just looking at the data how it is. In general, do batteries last more towards the upper end or the lower end? Well, once again, I have no idea. There are all these questions that you can't really answer if you're just looking at a long list of numbers, which is the data. You're going to have to organize this. So a lot of statistics is actually getting that data, but also knowing how to appropriately look at it so that you can gather some different information about it and look at trends and find information out from all the data. So what we did today was we talked about 3 different ways that you can look at the data visually and try to gather some information depending on what type of visual interpretation you're looking at. So this first part, preparing the data for visuals, says order the numbers from least to greatest. So I tried to do this by hand at first, and I was trying to find out what the smallest number is and the next smallest number, and it became a huge pain to be able to do this. And when it says determine the median, which is your middle number, that's very hard to do unless you go over and have it listed from least to greatest. And if you mess up on listing it from least to greatest, then you're going to get the wrong middle number. And then when it's asking for quartile 1 and quartile 3, which are talking about the middle of the bottom half and the middle of the top half, once again, that is near impossible unless you have this listed from least to greatest. So what I did was I did a little Google search and I found that you could put all these numbers in, even if they're not in order, into a Google Sheet. Once they're in a Google Sheet, you can work with that. So let me go ahead and pull up the Google Sheet that I had. Here is our Google Sheet. There's my Google Sheet. I listed all my numbers under the column labeled A. When I had that column labeled A and I had all of my values, beyond being able to organize this so it goes from least to greatest, I'm going to show you how to do in just a second. Not only that, but you're able to see how many values you have. Before I had no idea how many values, so it was kind of hard to figure out what the middle of all the values would be. But here you can see that there are 21 different values. Now the way that we're going to organize this, you want to make sure that you are inside of the column you're working with, and then you can click on this little button. You can go to sort from A to Z. Now, even though we're not going alphabetically, it will still go over and use the numbers and list them from least to greatest. Usually when things are being listed alphabetically, they'll put the numbers first from least to greatest, and then they'll go into the letters starting with A and going on from there. So now we have all of our values and we have them from least to greatest. Beyond that, we have the fact that there are 21 values, so we know that the 11th value will split the 10 on top and the 10 on bottom. So you know that it is going to be the middle number, which is your median, is going to be that 11th number, which is the number 9. Now, if this was an even number of data points, if there was only 20, you would have 2 numbers that are in the middle, the 10th and the 11th, and you would just average those together. But you're always kind of hoping that it's going to be odd, because when it's odd, then you are going to be able to just know that the middle number that splits it up is going to be your median. Let me go ahead and pull up what we were working on. So once again, I was able to arrange all my numbers from least to greatest, and they are listed on here. If you find the middle number, which is our 11th number, that is your median, it is 9. Now you have 10 numbers below that and 10 numbers above. Now, when you have 10 numbers below, that means that there is not a specific middle number. There's going to be 2 numbers that are in the middle. So what you can do is you can average those together, the 5 and the 6.5, and you get your answer of 5.75. That is going to be the Q1. Then you look at the top half, and the 2 middle numbers are 10 and 15, and you're going to average those and get 12.5. What we did from here is, even though it says dot plot goes first, I decided to do the box plot first. So how a box plot works is you are going to have a little number line, and you are going to have a mark on the end where you are having your lowest value, which was 3, your highest value, which is 17, Then you would have a mark in the middle of your box, which is your median. That is at 9. Then midway between that 50%, because the 9 now says that 50% of the values are less than 9 and 50% are more than 9. If you go over and find the middle, the median of that bottom half, you found out that that was 5.75, and that's the end of the box. And then you did the median of the other half, and you found out it was 12.5. So some people call this a box and whiskers, some people call it a box plot, but it gives you a lot of good information. It tells you the lowest number, the highest number, what is the number that splits the data up into 50% and 50%, and then we have quartiles, which means that it'll show where 25% of the information lies, the next 25, the next 25, and the next 25. So this is kind of nice. There are downfalls of a box plot. If I asked you how many values are there, you would have absolutely no idea. If I said how many values are in that 25%, you would have no idea, and you don't know what the values actually are. So this is good to figure out like how stretched out the values are, where 25% is, where the other 25% is. If I said the top 75% of phones have a battery life that is more than or equal to what, that would be 5.75. So there is a lot of good information you can get from a box plot. Not only that, but I asked the students, is the bottom 50% of the battery life or the top 50%? Which one is more spread out? And you can see that the top 50% goes from 9 all the way up to 17. That's a pretty big range, where the other one went from 3 to 9, which is only 6. So it's a difference of 6 versus 8. So the other values on the top 50% are going to be more spread out. The next thing that we looked at was more of like a frequency chart. So it's not really a frequency chart, but it's a way that you can look at frequency. So we were going to make a dot plot. I knew I was going to be going from 3 to 17. So that is a difference of 14. Now, normally I would just put down 14 tick marks, but I could see that some of the values were 0.5. So I decided to go, and instead of do 14 tick marks, I made 28 tick marks. And then I was able to go by 0.5s. So you have 3, and then you have 3.5 and 4 and so on. And since this is all arranged nicely using Google Sheets, I was able to find out that there are going to be 3 of the values, there's 1 value that is 3, there are 4 values that are 5. What's nice about this, you can kind of see how many of the values there are going to be at certain amounts. You can kind of see how it's spread apart. You can't figure out where the 25% mark is. You can't figure out what the median is very easy, or the Q1 or the Q3. You can still find out your lowest number and your highest number, but there's benefits of both of these. The big downfall of a dot plot is, let's say you had 50 different people who all had phone batteries that lasted 10 hours. It's going to be not the funnest thing to go over and have to put 50 dots on top of one another. So that brings us to our next one. The lazy mathematician in me, an efficient mathematician, says, I don't want to have to put 50 dots. What about if I just put a mark and I said it was 50 high? And that brings us to this concept of a histogram. Now, the main difference between a histogram and a dot plot is that you don't actually have to put the certain number of dots. And not only that, it's not going to just be a dot or a box or something representing exactly 3 hours. You're going to have a range, which I call buckets. And that's what they call them when you're looking at the Google Sheets as well. So it's going to be buckets. So we are going to group together everything that is between, in this case, I chose between 3 and 6, and then between 6 and 9, and 9 and 12, and 12 and 15, and 15 and 18. So I kind of grouped them together. Now, when I say between 3 and 6, that is 3 to 6, not including 6. 6 belongs to the next thing. And then you have 6 to 9, not including 9. 9 belongs to the next one, and so on. So when I looked at this, how many numbers are between 3 and 6, not including 6? I had 5 of them. So I went up and had the box go up 5 high. Then how many are between 6 and 9, not including 9? When I looked at that, it was 4 of them, and I was able to put my boxes. So this thing is called a histogram. You could always change the buckets at the bottom. We could have gone from 3 to 4 and 4 to 5 and so on. And I'm going to show you how to do that actually with the Google Sheets. So once again, you have to be the one to choose what makes sense for your buckets on the bottom. If they're too big, it does nothing for you. If they're too small, it's pretty much a dot plot. So let's go ahead and let me pull up this real quick. Here we go. So if you have the column that you're working with highlighted and you type on insert, and you go down to chart, it will automatically give you a chart that is going to be a histogram. Let me see if I can don't know if I can open this up. Let me pause and try to open this up so you can see. Okay, so this went over and made its histogram. Now the only thing here is the buckets, the thing at the bottom that it is using. It said from 3 to 5.9 and then 5.9 to 8.8. These are kind of interesting. I'm not in love with them. If I wanted to change those, what you can do is you can go to custom, you say I'm doing a histogram, and then it says bucket size. So let's say our bucket size was 17, or let's say 18. This is not completely worthless, but this is kind of a worthless histogram. The only thing this does is it kind of tells us that all the values are somewhere between 3 and 7.5, and that there were 21 people that went over and we got data from. But otherwise, it's not very helpful to just have one bucket. If you go to buckets of 0.5, let's say, you end up with this, and this is very much just like a changed up dot plot almost. You're not going to have like groupings of different ranges. This is truly like, oh, how many were at 3, how many were at 5, and so on. So this might be the buckets are too small. And then the buckets that we did was 3, and you can see that that is the graph. I kind of like that one. You could always try different ones and see if it gives you more information. For example, if I went to 2s, you could see that it changes what it looks like. When I was at 3s, you can see what the curve looks like. It's higher, then it drops lower, and then it goes even higher, then it's gone, and then it pops back up. And then when I go to 2s, you can see it's low, then high, then low, then high. And so when you decide on your buckets, it's going to change up the way that you look at the information. Let's pop back over here and keep looking. Let me see if I can. So let's look at the back here. That's mostly what this back part is talking about. The other thing, though, is if you have a bunch of numbers and they're listed, even if they're listed from least to greatest, sometimes it's nice to make this little chart. Like the chart is saying how many numbers are between 40 and 50, not including 50, how many are between 50 and 60, not including 60, and so on. And you could look at the numbers and you would be able to figure out how high your boxes are going to go in your histogram. So when we look at this histogram, the first one, when we are having your buckets going from 30 to 40, 40 to 50, and so on, you can see it. It looks like a nice curve, almost looks like a bell or something like that. Now, when we change from going by 10s and we go by 5s, you can see it looks a little bit different. You see that you kind of have this drop in the middle, whereas we weren't able to see that when the buckets were too big. We saw like this general shape of like a bell, and then this one kind of looks like that bell shape, but in the middle there is this time where it is going to drop down. So this is another example of a histogram and how changing the bottom axis, how that is going to change things and how you interpret your data. All right, let's go over the homework real quick. So on this first one right here, it says what is going to be the median. It's kind of hard to see the median unless you list out all these numbers. So the dot plot I changed just to be a list of numbers, and that way I was able to find out what the middle was. And there was 2 middle numbers, which were 8 and 8, and they averaged to 8. So the median is going to be 8. The next one, I knew my lowest number was 4, my highest number was 9. I was able to find my median was 7. The median of the bottom half was 6. The median of the top half, and those are your quartiles, was 8. And I was able to make my box and whiskers plot, also known as a box plot. That shows your bottom, your lowest number, your highest number, your median, the median of your bottom half, your top half, and it kind of shows that everything is clumped together a little bit more with the 50% that's higher than 7 versus the 50% that's lower than 7. On this one right here, we went over and made ourselves a histogram. So I made my little chart on the right to figure out how many numbers between 150 and 200, not including 200, between 200 and 250, not including 250. And once I got those, I was able to make my histogram. So that's my histogram. The one thing that I really should have written on here were labels. I forgot my labels. So you really should have labeled the bottom number of pages, and then the left-hand side would be the number of students. So go ahead and add that if you do not have that in yours. When I look at this one right here, what is the problem with this? Your intervals are just too big. Those buckets on the bottom, like you only have 2 different things we're looking at. You can't really see how the data is arranged. It's just 2 buckets. The boxes are pretty close to one another, so the intervals are just too big, so you can't really see the actual distribution. And then lastly on here, let me go ahead and drag this down. On this one, you were supposed to be interpreting our box plot. It says, what's the highest score? I'm going to guess that's about a 98. What was the lowest score? I'm going to guess that's about a 53. 50% of the students scored higher than what? Well, you know, that's the middle of that box, which looks like around 78-ish. And then the highest 25% of the students scored between what scores? That looks to me like 87 going to about 98. So once again, the main thing that we're talking about in this lesson is just, it's great to get the data, but if you don't go over and arrange it and make sense of it, the data is not that useful. And then you have to be able to figure out of the 3 ones we talked about, which one is the most useful. Do you want to know how many data points there are, or do you not care? Do you just care about like the distribution of them? So there's different things you can get out of all these different methods of arranging your data. All right, thanks for watching. Bye.